This manuscript explores life, death, what lies beyond, all through the lens of classical physics. This process of exploration has been a journey in itself, and we've made significant progress in developing this line of thought throughout our previous sessions. In this session, we'll delve into something really intriguing, a question that people have pondered over since the dawn of philosophy. Does the death symbolize the end? And you might be surprised to know that the answer lies in simple physics. It has been in front of us all along. Let us try to find the answer by starting with a simple comparison: a light bulb and a laser torch. Which one resembles the energy field that we radiate? A light bulb represents the source of incoherent radiation. The laser torch represents the source of coherent radiation. So, how does it work out for the light bulb? It emits the rays in multiple directions simultaneously. It's very difficult to focus tightly due to its lack of spatial coherence. You cannot put the rays of the light bulb coming to a specific area, a focused area, since it lacks the spatial coherence. It also has random phase relationships, resulting in waves that do not maintain a fixed phase difference. And relationship randomness prevents the formation of stable interference patterns. And it typically contains a broad spectrum of wavelength. Now, let us take a look at how it works out for the laser torch in the context of coherent radiation. The laser torch is highly directional, propagating in a specific and narrow path. It can be focused to a very small spot area with high intensity because of its spatial coherence. It maintains a constant phase difference across the wavefront and over time. And phase relationship uniformity allows for constructive and destructive interference. And it's often monochromatic, consisting of a single wavelength or a narrow band of wavelengths. That's how these two differ. The incoherent radiation coming out from the light bulb and the coherent radiation coming out from the laser torch. So, light bulb or laser torch, which one resembles human energy field radiation? Well, for sure, human energy field radiation resembles laser torch. It's a coherent radiation. Human energy fields radiates intense and coherent ELF energy, forming an ELF beam. So we've already discussed about this LC circuit. The energy in LC circuit is single sourced at death. There's no other similar source of energy present at that time. Electric field in the capacitor and the magnetic field in the inductor are both periodically oscillating and reinforcing each other. They are in sync constantly and maintains constant phase difference. And at LC resonance, this leads to a strong, balanced, and alternating system of electric and magnetic fields, which together can efficiently generate propagating electromagnetic waves of specific frequency, making it monochromatic in nature. So, single sourced, in sync for phase difference, constant phase difference, LC resonance leading to monochromatic radiation, it's all pointing to the fact that human energy field radiation is in the form of ELF beam. It's a coherent radiation. The ELF energy forms an ELF beam of energy. Now, there are some special characteristics of ELF beam. Let's look at what are those. An ELF beam of energy would be capable to maintain longer presence. So, coherent radiation can maintain its beam quality over long distance. That's the nature of coherent radiation. Now, due to ELF waves' extremely long wavelength, these can diffract around large obstacles and are not blocked by mountain ranges or the horizons and can travel around the curvature of Earth. And the attenuation of ELF wave in Earth's atmosphere is extremely low. All these points together ensure that ELF beam of energy is capable to maintain longer presence. Now, another interesting characteristics is that this there's a space between this conductive Earth's surface and the conductive B layer of ionosphere. It acts as a parallel plate waveguide which confines ELF waves, allowing them to propagate long distance without escaping into space. So, within this Earth ionosphere cavity, the ELF waves becomes standing wave and it can keep on propagating within this cavity and it remains there forever. So that's kind of a combination of characteristics coming out from the structure of the environment and the nature of the energy itself, putting together both of these aspects. Now, coherent radiation shows some special characteristics as well. And these special characteristics are visible during energy transfer, during constructive and destructive interference, during holography, absorption, and coherent scattering. All these are the kind of special characteristics that are visible for these ELF beams. So, death is not the end. Well, it does act as a stage of transition. It makes the human energy form transition into the ELF beam form, but it is not the end. This line of thinking we will continue developing further in the subsequent sessions. Keep watching.